Good morning. So, hopefully, you guys all had a nice weekend. I'm going to go ahead and take us through a couple things that some might find familiar, some might not, but it's going to tie into what we've just finished. What we've just finished is factoring. We took a quadratic equation. Typically, our quadratic equations look like this, where we had y equals x squared minus 4x minus 3, for example. Let's just change that so it's easy. Minus 5. And then we factored it. If we couldn't factor it, we would throw it into the quadratic formula. But what we tried to do was find factors and then get our answers. Like I said, we also talked about the discriminant just last week, and we said when you find the discriminant, you have a bunch of options. One, you can have a factorable one. You can have a non-factorable one, in which case you'd have to use the quadratic formula. And then lastly, you had no solution. So I'm going to quickly talk about what all this means before we get into what we're doing today, just so you understand. First of all, you have three options. One of them is to have an option just like this, where when you factor it, you get two answers. It doesn't matter whether they're rational solutions or irrational solutions, you have two answers. When you get two answers, what that means is that you have two x-intercepts, because that's what those are. They're x-intercepts. So what that means is we have a quadratic function that crosses the x-axis at 5 and -1. What we don't know is, does our quadratic open down like this, or does our quadratic open up like this? But what we do know is that those are our two x-intercepts. When we have an equation, something like this, and we factor it, and it's a perfect square trinomial like this, and we solve it and we get x equals -3. Well, that also tells us that that's our x-intercept. But now we only have one x-intercept, which means this. Again, still our x-intercept, but since it's at -3, that means our vertex is at -3, and it could be like this, or it could be like this. Now we'll talk about whether it opens up or down in a second, but when we have one solution, and it's a perfect square trinomial, these are the possibilities. And then finally, we could have a problem that looks like this. And then we throw it in and we're like, oh, well, we can't factor this. Can this be put in the quadratic formula? I don't know. Let's try our discriminant. So remember, our discriminant is b squared minus 4ac. And so we go b squared, which is what, 25, minus 4 times a, which is 1. In this case, c is 10. So 25 minus 40. Oh, look, we get -15 for our discriminant. So that means no solution. Now, it doesn't mean it can't be graphed. What that means is there's no x-intercept. So that's one of these cases. where you have a graph, but now it's up here or it's down here. But either way, it never crosses the x-axis. So there's no solution because our solutions are our x-intercepts. Now, real quickly, does it open up or does it open down? Well, that's simple. What does our a look like? Remember, in standard form, it's ax squared plus bx plus c. Our a is right there. If our a is a positive number, then it opens up. If, on the other hand, our a is a negative number, then it opens down. Okay? So since my a was positive in all these situations, everything opened up. But another story. Okay? So that's a quadratic. If you're having trouble, throw some of these problems into Desmos, see what it looks like. Now, before we get started in actually graphing these from equations, we're going to talk about a few vocabulary words. All right? Just two of them. That is our vertex. And again, the vertex is the point at which is the highest or lowest point based on whether it opens up or opens down. So our vertex is always this point. The next word or phrase, axis of symmetry. Well, with our axis of symmetry, what that is, it's an imaginary line that essentially passes through the quadratic and its vertex. Since it's a vertical line, it's always going to be x equals a number. Okay? But it means that everything is symmetrical. Everything here is the same as everything here, which means if I go up 1 here, then I go up 1 here. If I go up 3 here, I go up 3 here. Everything is symmetrical on both sides, so it's called an axis of symmetry. So in order to graph, we kind of need to understand the axis of symmetry and the vertex. Okay? Now, two forms we're going to talk about. Today, we're going to talk about vertex form. Tomorrow, we're going to talk about graphing from standard form. Okay? So graphing from vertex form. First of all, what is vertex form? Well, y equals a times x minus h squared plus k. Okay, what does all that mean? Well, h and k will always be numbers, obviously. And your a will also be a number, but usually it's just, for right now, we're just going to leave it as 1. So our a will equal 1 or negative 1. Again, a is what determines whether it opens up or down. So let me give you an example of one here. If I said y equals x minus 4 squared plus 3. Well, what do we get out of here? Well, our vertex is always h k. Here's the problem and where people get confused. Since this is minus h, it's always going to be the opposite of it. K is just plus k, so it's just going to be the same thing. So in our example here, we have x minus 4 plus 3. So our vertex is at 4, 3. Again, the opposite of what's inside here and the same as what's over here. So our vertex lies at 4, 3. So it's called vertex form because you can get the vertex directly from it. Now, I also told you that the axis of symmetry was important. Well, if you remember, I said the axis of symmetry goes through the vertex, and it's a vertical line. Since it's a vertical line through the vertex, in this case, our axis of symmetry is going to be x equals, what's our x? 4, so x equals 4. Let's try another one. Y equals 5 times x minus 7 squared plus 3. Well, we're looking again for our vertex and our axis of symmetry. Our vertex comes from our points here. It's the opposite of here, and then this one. So our vertex is at 7, 3. And our axis of symmetry is x equals, and again, 7. Let's try another one. Y equals negative 3 x plus 2 squared minus 8. We're looking for our vertex and our AOS. So again, we pull it from here and here. So our vertex is the opposite of what's in here. So since it's positive 2, now our vertex is at negative 2. It's the same as what's on outside, so negative 8. So that means our axis of symmetry is x equals negative 2, coming from right there. Now, something I added here, I added this in front. Again, that has nothing to do with our vertex or our axis of symmetry. That just tells us a little bit more about the shape and which way it opens. Since this happens to be a negative number, that would mean it opens down. Okay? So that's your vertex and axis of symmetry. Now, a couple different ways we can graph this, but I'm going to show you here next what this looks like. But again, why don't you guys throw these equations into Desmos and see what they look like. Okay, so let's work off of this equation. Y equals x plus 5 squared minus 3. Again, you should be able to come up with your vertex and your axis of symmetry directly from this equation without having to do very much work at all. Our vertex would be at negative 5, negative 3. Our axis of symmetry would be at x equals negative 5. So right away, what we're looking at, if we were to graph this, is our vertex is there, and then our axis of symmetry is right there. Since it's positive, I know it's going to open up. So I can kind of look and say, oh, the graph's going to look like this. But I probably want a few more accurate points than just kind of assuming. And so again, several different ways to do this. What we're going to look at is a table. And we don't have to do a ton of points, but since we know it's symmetrical on both sides, what we probably want to do is just graph, all right, what would it look like if I moved out in each direction one space? So what if my x was at negative 4 or negative 6? Because again, moving out in one direction puts my x at negative 4 or negative 6. Well, if I throw negative 4 in there, I've got negative 4 plus 5 squared minus 3. So negative 4 plus 5 is 1, squared is 1, minus 3 is negative 2. What if now I throw negative 6 in there instead of negative 4? Well, negative 6 plus 5 is negative 1. Negative 1 squared is positive 1. 1 minus 3 is, again, negative 2. And guess what? That should make sense to you, because remember what we talked about is that as you move away from the axis of symmetry, how it goes up is exactly the same. So if I take one step out in both directions, the y value will be the same. Likewise, if I take 2 steps out in both directions, and now I move over 2 spaces in both directions, so now I'm looking at my x being -3 or -7. So if I throw -3 or -7 into my equation, now I have -3 plus 5 squared minus 3. -3 plus 5 squared is 2 squared 4. 4 minus 3 is 1. If I throw -7 in there, -7 plus 5 is -2. Squared is +4 minus 3, again, is 1. So now I'm able to paint a little bit more accurate picture of what the graph is going to look like. And if I continued, I'd have -4, -2 right here, and -5, -2, and then I have -3 at 1, so right here. I'd have -7 at 1. And so now, if I were to graph, I'd have a little bit more of an accurate graph with that information. So what you're going to be able to do is do a table to guesstimate some points. Okay? Okay, last 2 types of problems that you're going to run into. Still in vertex form. One is when you don't have anything in the parentheses, so it's just y equals x squared minus 6. Well, what you want to look at that is as y equals x minus 0 squared minus 6. You don't have to have the minus 0 in there, but since there's nothing in the parentheses, we assume that the x coordinate is 0. The y coordinate is then -6, so your vertex is at 0, -6, with an axis of symmetry at x equals 0. The other type of equation you're going to come into is when you have something inside the parentheses but nothing outside. Again, just assume that what you're missing is the plus 0 or minus 0. Again, so now your x-coordinate, the opposite since it's inside the parentheses, would be 4, and your y-coordinate would be 0, which puts your axis of symmetry at x equals 4. So hopefully this helps you understand what vertex form is and what it looks like. Again, I would throw some of these in Desmos. You're not going to have to graph today, but just to understand these, throw these in Desmos and see what it looks like.